Lesson 11.2 and 11.3, our outcome. We will define, now we're going to define theoretical and experimental probabilities. And we're also going to make predictions with these probabilities. Okay, first things first. Suppose I have a jar of marbles. What is the probability I pull out a red marble? So again, just looking at my jar of marbles here, how many reds do I have? I have 2. That's my favorable outcome. But how many total outcomes did I have? There are a total of 10 marbles in there. So my probability now becomes 2 out of 10. However, what did I tell you to do with those fractions? Reduce them if you can. And this one we can't. So that would become 1 out of 5. All right? So that would be our probability. Is this probability theoretical or experimental? This is a theoretical probability because it's based on a theory. It's the perfect world scenario. I have marbles in a jar. If I just randomly reach my hand in a perfect world, what is the probability I'm going to pull out red? I have done no experiment at all. I'm just reaching my hand into a jar. Okay, so theoretical is based on theory. I like to call it the perfect world scenario. Okay? Suppose I have a jar of marbles. What is the probability I pull out a red marble? Now this time I didn't give you the picture of the jar of marbles. I gave you this data table and this little cloud bubble that says how many total pulls did I do. So when you're writing probability, it's your favorable outcomes over your total. So in this case, I didn't tell you how many total outcomes I had. How many did I have? I hope you're saying 20. Because I did 3 red, I pulled out 3 red, put it back, pulled one, put it back, pulled it, put it back. So I had 3, and then I had 4 blues, 7 times I pulled green, and 6 times I pulled yellow. Okay? So I did total of 20 pulls. This time I'm looking for red, so it's 3 out of 20. Okay? This is based on an experiment. Somebody actually did this. They sat there and they did 20 pulls of marbles and they saw what happened. A lot of times we do this with flipping a coin or rolling a dice. It's based on data. Okay, so let me get this guy out of the way. Go away. And there it is. Experimental probability is based on data. And this data could look a lot of different ways. You can have it in a function table like this. You can have it in a line chart where there's little X's above it. You can have it as a frequency table. There's all kinds of ways that are going to show you the data. The point is, experimental is based on data, and you have to add up how many total outcomes you had, or how many times you performed the experiment. All right, making predictions with our probabilities. So, if I do 20 pulls, how many times will I pull a red marble? Again, I just gave you the jar of marbles. Is this theoretical or experimental? It's theoretical. And if I did 20 pulls, again, red marble, what was the probability of my red marble? It was 2 out of 10, or 1 out of 5 for our simplifiers. Okay? If I'm going to do it 20 times, what do I have to do with this 2 out of 10 and 20? I hope we're saying multiply. You have to multiply. So 2 over 10 times 20. Okay? Yes, you can type in your calculator 2 divided by 10 times the 20. Or we can use our algebra skills and look at this. So we have 2 over 10 times 20 over, why can I put 1 over under the 20? Yeah, because that doesn't change the value. 20 divided by 1 is still 20. Now watch what happens here. Can I do any canceling to make my numbers smaller? Yep. 10 goes into 10 one time. 10 goes into 20 2 times. Now look at that. 2 times 2 is 4. And behind the red door, 4 times I would pull a red marble. So if I did 20 pulls, I would expect to pull a red 4 times. Now, that's in a perfect world. Is that actually going to happen on our experiment? I don't know. We didn't do it. But it could. So here's another one. Making predictions from our probabilities. So now you're given the frequency table and you're asked to do the same thing. Are you doing a prediction on theoretical or experimental data? Experimental. This is our frequency table. Somebody did this experiment. Maybe it was you. Now we're going to make a prediction. They pulled 20 times. I want to know if you pull 50 times, how many blue marbles should I expect to do? So I want you to pause this and I want you to try to set it up on your own and find out the answer. We should have 4 out of 20 because that's what the experiment provided us, times the 50 if I do it 50 times. Okay? I end up with 200 over 20, which finally brings me to 10. So if I sat there and I made you pull that marble out 50 times, you should get blue 10 times. Okay? And there's the answer. 10 times I would pull, oops, that should say blue. All right, here's ones that I want you to practice on your own. Pause it now. I'm going to read it, and then I want you to pause it and actually look at it and try to figure it out on your own. Your sock drawer is a mess. You just shove all of your socks into the drawer without worrying about finding matches. Your aunt asks you how many pairs of each color you have. You know that you have a total of 32 pairs of socks, or 64 individual socks, in 4 different colors. So you have white, blue, black, and tan. You do not want to count all of your socks, so you decide to randomly pick 20 socks. Okay, so you don't know how much of each one you have. You just know you're going to reach in your drawer and pick 20 times. And predict the number of each color from your results. And here's your table shown below. So you did 20 picks, okay? Every time, 12 times that you reached into your top drawer, you found 12 white socks. 1 time you got a blue sock. 3 times you got a black sock. And 4 times you got a tan sock. What is the experimental probability of choosing each color of sock? Okay, so sock, not pairs of socks, but sock. Okay, so experimental. How could you write each of these as a probability? I want you to pause this. I'm going to be looking for this and answer this question. Here's the answer. The experimental probability of choosing a white sock is 12 out of 20. Okay, I have 20 pulls. Okay, 12 times I got white socks. So my probability of that is 3 out of 5. The experimental probability for blue was 1 out of 20. Experimental for a black was 3 out of 20. And tan was 4 out of 20, which simplifies to 1/5. Okay, that's my probability for choosing each type of sock. I still don't know how many exactly I have of each sock, but we're going to answer that in just a moment. All right, here's the same question. All I did was, same question, and then this part is different. Based on your experiment, how many of each sock do you think is in each drawer? So you already found the probability for this. This is 12 out of 20, okay? So this one is 12 out of 20. That was the probability. This one was 1 out of 20. This was 3 out of 20. And this is 4 out of 20. What is the experiment, or based on the experiment, how many of each sock do you think you have in each drawer? Each sock. So I'm looking at individual socks. Well, I know 12 out of 20. If I do 20 pulls, then I would have, it would be 12 would be white. But what if I had 64? So here we're asking for a prediction. So what do you have to do with 12 over 20 and 64? You have to, oops, I don't want to show you all of them, multiply. Okay? So do that. Set this up as a multiplication problem. So here, my probability of pulling white times the number of socks I know I have. I know I have 64 socks, okay? So multiply that. Get out your calculator and type it up. Figure out about how many socks you have of each one. I can tell you it's not going to be perfect answers. They're going to be decimals. So do that for the white, blue, black, and tan, and then come back to me. And there they are. Let me get rid of this. Cut. And let's go full screen so you can see that. So here it is. Of the white socks, 64 times 3 out of 5, or the 12 out of 20. It's just simplified. So I have approximately 38 white socks. Blue socks, I did the same thing. I should have 64, but I got a 1 out of 20 probability. I have about 3 socks, 3 blue socks. Black socks, I have just over 9, so I might say 10, about 10 socks. And tan socks, 64 times 1/5, and I have about 13 white socks. Again, they're approximate numbers. You don't know. You didn't actually count them. This is all based on an experiment. But this is making a prediction. If you didn't do this part on your own, please pause the video and go back and do it on your own. Okay? Because this is the really important factor of this lesson. Theoretical and experimental, but mostly making the predictions.